In this video, we will load fluorescence data into Blender, which is a very powerful 3D rendering software, using the add-on Microscopy Nodes. So, for this, we'll first delete everything that is preloaded in our scene, the camera, cube, and light, by pressing A and then pressing X. And then we get our Microscopy Nodes panel. If this doesn't show up for you, you should first install Microscopy Nodes. That is a separate video that will pop up right now. And with our Microscopy Nodes panel, we can now put in our dataset. Our dataset can be either a TIFF or an OME-Zarr. So for an OME-Zarr, we can put in the link to a local Zarr or a file on the internet. So I've put a file on the internet that we can load, which is also showing up on the screen and is in the description. But you can also, of course, use your own OME-Zarr or your own TIFF. So, we now have our RPE1 expansion microscopy cell, and we can pull this out a bit to see all of our options. So first there is an option to which scale we want to load it. Because this is an OME-Zarr, there's multiple scales that the data exists at, where these numbers indicate how many pixels each axis is. And these one with the warning signs, they don't always work in Blender. They only work in the ray traced pipeline, so they're a little bit harder to use. So right now we'll use this one with the volume icon, so the S2, and we can see that it reads out from that file also the pixel sizes, where we can change the pixel size unit or the actual pixel size itself, but because it reads it out correctly, we can leave it as is. And then we can find the different channels that are in this dataset. So for each channel, we get the name, which we can change, whether to load it as a volume, as a surface, or as a label mask. In this video, we're only going to be discussing the volume loading, and I'll do the surface and label mask loading in a further masking video. Then there is a light bulb, which says whether it emits light or whether it scatters light after it's loaded. And then there are the color maps. So here we can pick a color if we press this thing, and I'll put this back to white actually, or we can pick a nonlinear color map if we want. So then we can press load. And what it does is it loads the data from the internet, and it writes it out into whatever folder is set here. So right now this is in temporary storage. Now we have our block, which is not yet data, but this contains our loaded data. It's just not being visualized right now because we're not in the right render mode. And to change render modes, we can do up here. So we're now in this solid mode, and then we can go to the rasterized view, where we can already see, and we can go into our ray traced, which is the furthest on the right here, and we can see it even better. Additionally, we can still turn off certain channels. So for example, the acetylated tubulin, because it's only for the centrioles, it's not really going to show up very much, so I'm going to turn that off and press reload. And we can also still change the colors in here. So we can make this pink, or we can make it a Faraday axis. We have here all the components of our thing. So here we have our axes, and if we want to select how to change our axes, we can go here to the wrench icon, to the modifiers, then we can, for example, say, oh, I don't want this to have a grid, and then it will just be a flat box, or I want it to have a grid, but I want it to have a different amount of microns per grid line. So then it will become way denser. The slice cube, which slices our object, which is so we can move this in multiple ways and then slice our object, and then we can also rotate and animate this movement or scale the slice cube. So this is very flexible. If we want to get to our pixel intensities, we press the volume, and then we can go to its material here at the bottom. and then we get the materials for each of the channels. And then, for example, now in the NHS ester, we see that we've loaded this Viridis map, and here we have our pixel intensities. Under the gear icon, we also can just turn off a specific channel. And then if we're in the tubulin channel, we can include more of our beautiful tubulin staining. And we have here our nucleus. And then what's also useful to know is that we have a shading tab where we can see even more of this. We have a bit different controls, but it's essentially the same thing as we have here in the material. We can now go to the ab-tubulin volume, and then we see our histogram, and still change here as well our intensities. And then here we can still change our color map, so we can still press the point on the right here and change the color, or we can also right click it and then select from our very long list exactly which lookup table to use. So this is, in a short overview, how to load volumetric data, fluorescence data in Blender, and how to make it look pretty. But of course, with animation of the slice cube and with masks and further visualizations, a lot is possible. And I want to show one more thing. So this is, if you want to know much more about it, it is useful to go to the electron microscopy video, because this is the default from electron microscopy, is rendering it not as emissive, but as a density render. This is the basics of the Microscopy Nodes interface and just loading volumes. Thank you for watching, and I hope you join us for the more advanced tutorials.